Okay, welcome back to part 2. You've had a chance to look it over. My class is a little stuck. You're looking for a very sophisticated answer, I think, aren't you? Yeah. Well, what you want to know is that the coyote hit the ground with a certain energy, correct? Yes? Hit the ground with a certain energy. And that energy was used up when it made that dent. Would you agree?
Yeah.
Yes or no?
Yes.
Okay. So the energy, in other words, let's look at, we're going to take that very small dent and we're going to blow it up. Okay? We're going to blow it up. Is that all right? So here is the dent, correct? That's the dent, right? Now that dent has a height, would you say? Or we could say a distance, right? That dent, would you say that's correct? Now, what was the energy here? What was the energy that it started with here? What energy did it have? Do you agree that it hit the ground with a certain energy up there? And that energy was 0 when it was at the bottom of that dent. Would you say? Because it stopped moving, right? What's the energy of something that stopped moving? It's 0. I'm not talking about the internal energy and the energy of the bonds, but in terms of potential energy, kinetic energy, force times distance, the energy is 0, correct? Okay, it used it up. So do you understand that right here, this energy is going to be a potential energy? Do you understand that? Now we think of that as being like this, right? So it drops, correct? So it has a certain potential energy that it has when it hits when it goes to the bottom, right? Okay. Well, what energy did it start with right there? How do you know? What energy did it start with? Well, how far did the coyote travel down the canyon off the cliff? It traveled 30 meters, correct? It traveled 30 meters. So the distance or the height it traveled is 30 meters. And it has a mass of 20 kilograms. We know G is 10 meters per second squared. Why do we say 10 meters per second squared and not 9.8? Just yeah, it's easier. Somebody put a posting on one of my sites, physics sites, saying to me, as if I didn't know, that the acceleration due to gravity is not 10, it's 9.8. So there. Well, the reason you use 10 is not because it's easier, which it is, but because it allows the student to estimate. Because it's the process of solving the problem that is more important than the actual solution. So if you have a situation where you can actually see if the process is correct as you're doing it, it makes the learning better. Would you agree? You have to be able to estimate answers. And 10, we work in a world with base 10. So it's, yeah. Okay. So, what energy did it have when it hit the ground? 600 newtons?
Oh, energy?
Wouldn't it be mgh?
Yeah.
Isn't that the potential energy it has when it hits, when it
Which
Yeah.
is 600 still.
600?
Yeah. 30 times 20. Oh, 30. Oh, 6,000.
30
6,000.
6,000.
times 20 times 10.
6,000.
6,000. So it has 6,000 joules when it hits the ground. Would you say that's correct? Yes? Yes? Now, so it used up 6,000 joules to go from here to here. Would you say that's correct? Is that true? It used up 6,000 joules to travel that distance. Yes? Correct? So would it be, what equation allows you to,
W equals FD.
what is it?
W equals FD.
W, well, what am I looking for?
Force.
I'm looking for the force, right? So, how do I calculate, what's the relationship between this distance here and the force? What slowed the Coyote down? What slowed it down?
The force.
The ground slowed it down, didn't it?
Yeah.
And read to me the last sentence of the problem.
What force does the ground exert?
What force does the ground exert
Yeah. On the Coyote as he makes a Coyote-shaped dent?
on the Coyote as the Coyote makes a Coyote-shaped dent? Coyote. I love it. I am from Bahrain. Coyote. I like it. I like that accent. You're really from Brooklyn, right?
Where's that?
Are you from Flatbush?
Where's
He
that?
pretends he's from the Middle East, but he's actually from Flatbush in Brooklyn.
Down by Bahrain.
He's trying to convince me that he has this great Arab accent. He has a great accent, but it's fake. Okay, so so I want to know how much force the ground exerted to slow this Coyote down so it stopped. So what equation? I have the potential energy. The potential energy is
6,000.
mgh. So what's mgh going to equal?
FD.
FD, right? FD. And this F will be ground exert.
Distance is
Won't it? Correct? So, what's the force?
We're trying to find.
What's the force? We're trying to find that out though, right? But do we know the distance?
Yeah.
So therefore, I divide both sides by distance. So I have force, let me write it in a different color. I have force equals
6,000.
mgh over d, correct?
Yeah.
Yes?
Yes.
I have more space over here. Is this coming up on the board?
Yeah.
Can you hear me over there?
Your face the
Excellent! Coyote! Muy bien, okay! So you say force equals
6,000.
6,000 joules over the distance, which is what?
0.42.
0.42. This distance here is 0.42 meters. Would you say that's correct?
Yes.
Is that what the problem gives?
Yes.
So, what force was exerted on the Coyote to stop it?
14.
Right? So, divided by 0.42 meters equals what? What's the answer? Anybody have an answer for me?
14,285.7.
14, let's round that to ones place.
14,286
14,286
newtons.
newtons. Okay? You get it? Easy? Now, these problems are all the same. You're simply using the three equations when you're talking about potential energy and things, right? Let's list the equations on the board that we're doing. Okay, what are the equations that we use? For this, we use force equals mass times acceleration. Work equals force times distance. We have kinetic energy equals 1/2 mv squared. We have potential energy equals mgh. Is that it, pretty much? Yes? Okay. We sit on the chairs correctly, Omar, correct? Where we put it in the down position, right? The low position. Okay. Everybody loves playing with the chairs up and down, around, over. We're in a new lab. And my students have never used chairs before.
Except for
They always stand. So this is the first time they've ever used a chair. So they don't know how to actually use one. So we're in the learning process. We're learning physics and we're learning how to use chairs. Okay. Now in Bahrain, do you use chairs? Okay. All right. Okay.
So we use rugs there.
Oh, use rugs. Excellent. I like that. I have some really nice rugs in my house. I have pictures of my rugs.
Persian rugs?
Well, I think they're actually maybe from like Bahrain, but I'm not sure. I don't know where they're from, but they're really nice. Okay. Now, so let's do another problem. This is end of Coyote problem 2, yes? We're off.